Well, hello and welcome everyone to tonight's event about localized climate projections with climate service specialist for the province of Nova Scotia, Alex Cadel. And my name is Dylan Yates and I work with the Nova Scotia Environmental Network. So NSEN is a network of 30 plus environmental organizations whose common purpose is to conserve and enhance the natural environment and build a sustainable future for Nova Scotia. And we are so excited for this event. And I think last I checked, we hit 115 registrants. So that's amazing. So with me this evening, I have a very special guest, Jeff Ward from the Membertou Heritage Park. Jeff will start things off for us with an opening prayer and land acknowledgement. But before I pass things off to Jeff, I just have a few housekeeping notes. So everyone in the Zoom call will be placed on mute until we get to the question period. So for folks who have questions for Alex, when we get to the question period, you could post your question in the chat, or you could raise your hand and we'll get to you individually and unmute you at that time. And yeah, I'll pass things off to Jeff, and yeah, can't wait to get things started.
Quay, medalotio, Minalois in Amakodagos, in the Lewin, Medabadankia, Kisnadawigi Mahabatu. Today is a great day. As I mentioned, my name is, I share my spirit in the dancing song. I'm originally from Red Bank First Nation, born and raised, and currently live in Membertou, Malbak, Membertou. And the most beautiful, amazing woman captured my heart and said, "You stay here." And I said, "Yes, dear." My life got so much better. Just those two words, "Yes, dear." It's like a prayer was answered. So I come to you with a prayer. And I want to invite everybody here to the Membertou Heritage Park too as well, just to make sure that you all know that you get 10% off everything at the gift shop. 15% for snow on the roof discount. You know what I'm talking about. My buddy Paul out there, he knows what I'm talking about. Snow on the roof discount. Anyway, it's good to see all these beautiful faces and beautiful people. We're going to start off with a prayer. And I'm going to say it in my language, and I'll share it in English too. I'll do it together, simultaneously. And about bringing things together in a good way. The prayer goes like this. Gemmi data minute. Let us honor the people we are. My people, let us unite. Let us honor our ancestral lineage. My people, let us help one another. Let us help each other the way our Creator has placed us here upon Mother Earth. That prayer, all my relations, that prayer is not only a prayer, but it's a song called the Mi'kmaq Honor Song. And I like to give thanks to the elders and to our ancestors for passing on those words and knowledge, and most importantly, passing them on to my Uncle George Paul when he fasted in the mountains. And I was just a little kid when I was there, when the ancestors came to him, gave him that message. And that's so important that we pass on that message to all our brothers and sisters here, and that we're here. That's why we're here together, to help one another. And as we begin, and before we begin, I would like to acknowledge that we are, and you are, in Mi'kmaq. I'm coming to you live from Unama'ki, which is in Cape Breton. And maybe you're all in Cape Breton, I'm not quite sure. Maybe you're in other districts. That's the power of internet. It could be from all over the world. This is the ancestral and unceded territory of the Mi'kmaq people. Unceded territory of the Mi'kmaq people. This territory was covered by treaties of peace and friendship, which the Mi'kmaq, Holistic, and the Passamaquoddy first signed with the British Crown in 1725. The treaties did not deal with surrender of lands or resources, but in fact recognized the Mi'kmaq, Wolastoq, and Passamaquoddy title and established the rules for what was going to be an ongoing relationship between nations. We are all treaty people. All my relations, Tahoe. Once again, please reach out at any time, come to member two, or consult with your local elders at any time. It's about working together. And we talk about reconciliation. We must recognize that real action, but don't forget the truth before reconciliation. We cannot skip to reconciliation, truth and reconciliation. I wish you all a beautiful, amazing meeting today. Thank you, Tahoe. And thank you for acknowledging me and allowing us to come in a good way and to share it within a good way.
Thank you, Jeff. It's always so nice to have you at our events, and we really appreciate everything that you do. And I'll now pass things off to Alex and give him the floor to get things started.
Wonderful. Well, all in, Jeff, for the lovely opening there. And thanks, Dylan, for the introduction. Just bear with me for a moment as I share my screen here. Sure that's coming through okay. And for myself, I should say I'm coming to you today from Dartmouth, Nova Scotia, within the traditional Mi'kmaq district of Sebek-Anagatik. And from the few messages I've seen popping up, we've got representation from around the province, which is absolutely wonderful. So really today, I'm here today to talk to you about climate change projections for Nova Scotia. I mean, the climate change conversation is certainly ongoing, but I think this turned out to be particularly timely. If you hadn't seen yesterday, saw the release of the Intergovernmental Panel on Climate Change's Working Group 2 report for the 6th assessment report, which dealt with impacts, adaptation, and vulnerability. So I've seen a lot of conversation on the last 24 hours or so around climate change. And I think it's a nice opportunity for us to bring this back and talk about what it means for us. So really what I'll be talking to you about over the next, 45 minutes or so, maybe less, leave a bit of time for questions at the end, is helping you to better understand the magnitude and timing of some of the climatic changes that we're expecting in Nova Scotia, in the hope that this provides some clarity on how climate change may directly affect you, your community, and the work that you do. So before we get into that, I just want to briefly introduce CLIMAtlantic, which is one of the organizations I work with, because I think that does help to provide some context for why I'm talking to you today and what angle I'm approaching this topic from. So CLIMAtlantic is a new regional organization that was developed to facilitate access to regionally relevant climate information and support its effective use in planning and decision-making. We're a nonprofit organization that's funded by the federal and provincial governments. And for myself, I also work in a shared role with Nova Scotia Environment and Climate Change. And CLIMAtlantic, we work in collaboration with and in support of existing initiatives. So we're very user-driven. And in addition to working with the provincial government, I also work directly with municipalities, First Nations communities and organizations, NGOs, industry, private citizens, really anyone who's trying to better understand climate change and what it means for them. CLIMAtlantic and myself for Nova Scotia are here as somewhat of a resource for that. So within our mandate to deliver climate services, provide access to climate information, build local capacity, and offer training and support through things like this webinar. So again, I just wanted to thank you all for taking some time on a Tuesday evening to learn a little bit more about climate change. So to get into it here, as a quick overview of what I'll be talking about over the next little while here, we'll start with just a quick overview of Earth's climate system and just talk about projecting future climate, just so we're all on the same page about where this information is coming from. And then we'll talk through a series of 5 key messages that have come out of the updated projections work that we've been doing recently that we think Nova Scotians should be aware of. These being it's getting warmer, precipitation patterns are changing, we're expecting more frequent and intense storms, sea levels are rising, and our oceans are changing. And we'll talk through some of the data and hazards associated with each of those. And end with a few final thoughts on what we do with all this information. But to jump into things here, let's start with talking about weather. It's something we're all very familiar with, these day-to-day changes in Earth's atmosphere. We know that sometimes it's hot or cold outside, wet or dry, sometimes cloudy or windy. But sometimes we might ask ourselves this question of, if I'm going outside today, what should I wear to be prepared? And that's where we're thinking about weather. When we're talking about climate, on the other hand, we're talking about the long-term patterns and averages of weather over periods of at least 30 years is what's recommended by the World Meteorological Organization. That's what we can start referring to as climate rather than just a shorter-term trend in weather. So relating that back to the clothing question, thinking about climate, we might ask ourselves, what clothes should I have in my closet to be prepared for the typical weather patterns in the area in which I live? Now, Earth's climate system itself is driven by energy in the form of heat from the sun. And it is the uneven heating of the Earth's surface that drives this complex three-dimensional global circulation of air and water that's represented in that diagram on the right there. But ultimately, the energy that enters our climate system is relatively the same as the energy that leaves it. It's a system in relative equilibrium, unless there's some sort of change within the system. And that's where greenhouse gases come in. These are compounds that, just due to their molecular structure, are very effective at trapping heat within the atmosphere. And this includes things like carbon dioxide, methane, nitrous oxide, and various fluorinated gases as well. And the concentrations of all of these compounds are increasing within our atmosphere due to human activities. I'm not sure how readable the scale is on the chart that I've included here, but this shows CO2 concentration in the atmosphere over the last 10,000 years, which is certainly the period of time most relevant to human civilization, at least. And over much of that time, we can see CO2 concentrations varying from about 260 to 280 parts per million, but quite stable until we get to this period a few hundred years ago that coincided with the onset of widespread, exponentially increasing human use of fossil fuels. You can see how dramatically that graph of CO2 concentration spikes. And so far, the trend has been for global emissions to continue increasing each year. And while there have been numerous international commitments to reduce greenhouse gas emissions, many of those do still lack a concrete plan on how those targets will be met. So that is to say, there's been some encouraging progress in recent years, but we do still have quite a long way to go to curb our emissions and return to the state that we have been in for centuries and thousands of years, really. So just as of a couple of weeks ago, February 14th, the latest CO2 reading in the atmosphere was up over 420 parts per million. The other point that I wanted to make here was the long residence time of greenhouse gases in the atmosphere. And what I mean by that is that once these compounds are emitted, it often takes decades and sometimes centuries for them to naturally break down or be withdrawn into other processes. So really, once we make the choice to emit greenhouse gases, we've signed ourselves up to deal with the consequences for decades and in some cases centuries to come. I think that's important to recognize. So if we know greenhouse gas concentrations are increasing, you might ask yourself, have we already seen an impact on the climate? And if you're here, you're probably not surprised that the answer is an emphatic yes. So the climate, as we have seen in recent years, has warmed at quite an unprecedented rate, at least within human history. And that observed warming is driven by emissions from human activities. So again, the chart here is just showing observed emissions compared to simulated human processes versus only natural. And it's very clear through this and other detailed detection and attribution work that humans are the cause of the climate change that we're experiencing. That's also driving many observed changes in weather and climate extremes. And I'm sure many of you on the call have your own examples of how you've noticed things happening recently that aren't quite normal. So just so we're all aware, the latest estimate for global surface temperature increase is that we've experienced an increase of about 1.09 degrees Celsius for the most recent decade, 2011 to 2020, compared to pre-industrial. So when scientists and global leaders are discussing the need to keep warming below 1.5 or 2 degrees Celsius to avoid dangerous consequences, I think it's important to recognize that we're already most of the way there and need to do a lot of work to slow down our trajectory. And of course, we have other important sources of evidence for climate change in our region as well. And I wanted to specifically mention local Mi'kmaq knowledge, for which there is 13,000 and more years of ecological pattern recognition that is built into this. And traditional knowledge does absolutely help us to understand climate change. So there's a very strong link between nature or the land, as well as Mi'kmaq culture and language. And I think one really nice example of that is the Mi'kmaq calendar, which is based on moon cycles and different biophysical indicators. So for example, if we look at the moon of Sigilgoose, which corresponds roughly to March, which is maple sugar time, or Nipnagoose in June, which is when the trees are supposed to be fully leafed, or something like Giptagewagoose, November, where the rivers start to freeze. We start to identify areas where biophysical patterns are already departing from what used to be considered normal for our territory. And there's certainly ongoing Mi'kmaq-led work to monitor and understand environmental change in our region of Mi'kma'ki. And I think that's just important to highlight in the climate change conversation. But all of that considered really through multiple lines of evidence, we know that the climate is changing, we know the cause. So I think a natural next question leading on from that is, where are we headed? And that's what I'll be spending the bulk of today's session talking about. So to start here, let's talk about projecting future climate. And for this, as you may be aware, climate researchers and different institutions around the world use an ensemble of complex climate models that simulate the physical, chemical, and biological processes in Earth's land, atmosphere, and oceans. And the results that come out of these models, what we call projections, help us to better understand the long-term patterns and averages of the climate system. So again, a reminder here that models aren't attempting to forecast conditions at a specific point in time, the way that a weather model might, but rather to help us understand what the average conditions in a future period of time might be. Due to computational limitations of these very complex models, we often have to further downscale the results that come out of them to be more relevant to our local area. So for most of the data I'll be talking to you about today, just know that it's coming from an ensemble of 27 different climate models that have been statistically downscaled to an approximately 10 kilometer by 10 kilometer grid bounded to the borders of Nova Scotia, which is really all just to say that the data I'm talking about is locally relevant and it is scientifically sound. Now, I think it's also useful to acknowledge that there are sources of uncertainty in climate projections, but well, I guess both due to the chaotic nature of the climate system that we're trying to model, as well as the impacts of human decisions. But the causes of that uncertainty are quite well understood. And the consensus is certainly that we have enough information to effectively take action. Now, one of the ways that we deal with uncertainty in climate change science is through the use of scenarios, which are plausible descriptions of how the future may develop. Today, we'll be focusing on data coming from RCP 8.5, which is a high emission scenario. In this case, RCP just stands for Representative Concentration Pathway, and the number, in this case 8.5, denoting the change in radiated forcing in watts per square meter that level of greenhouse gases would result in. And the reason we're focusing on that scenario today is because it does most closely match the increasing trajectory of global emissions to date. However, one message that I think is always really beneficial to get across is that the results are actually quite comparable across scenarios for at least the next several decades. I'm not sure how well my mouse shows up here, but you can see that at least until around 2040, 2050 or so, whether we're looking at a high emission scenario or our most optimistic low emission scenario, we've got quite a good understanding of where we're going in those decades to come. And that's a reflection of our climate system adjusting to the greenhouse gases that we've already emitted. Now, our decisions today do still absolutely have a very significant impact further into the future. But at least for that sort of mid-century timeframe, like I mentioned, we've got quite a good understanding of where we're going. And that rate of warming that we are already currently experiencing will result in some quite different climate conditions by mid-century. So again, just sort of looking at 2040, 2050 in this graph here, where scenarios are quite consistent, and comparing that to the historical climate conditions represented by that gray envelope there, we can see that it's already quite substantially different from what it used to be. And that's a bit of an issue because many of our built and natural systems are designed for and adapted to the range of historical climatic conditions that we are departing from. So with that context out of the way, let's get into what this means for Nova Scotia specifically. So as I mentioned off the top, we'll be going through a series of 5 key messages that we think Nova Scotians should be aware of, starting with this one of it's getting warmer. So we have a lovely full chart here of temperature projections for Nova Scotia, and let me just break down what we're looking at here before we start walking through it. So on the left-hand column, we have a number of different parameters or indices related to climate, related to temperature projections, and I'll talk through each of those in turn in just a moment. And then we have results for 3 different time periods. First, our baseline period of 1981 through 2010, and this represents our historical climate, and it's aligned with historical observations and represents what our climate used to be. The middle column there, the 2050s, representing 2035 to 2065, shows, as I mentioned, kind of what we're on track for regardless of the emission scenario that we choose. And this represents more or less the minimum of what we should be preparing for at this point in time for mid-century. And then finally on the right, we have data for the 2080s, which represents 2065 through 2095. And this is what we're on track for under that high emission scenario that I mentioned. So we do still have an opportunity to pull ourselves off of that pathway, but that would require some relatively immediate and relatively drastic reductions in global emissions. And the values you're seeing specifically in that chart are the medians of the multi-model ensemble that I mentioned. So that context out of the way, let's talk through what this actually looks like. So for mean temperature, for example, on our baseline, we used to average about 6.6 degrees Celsius as our average temperature over the course of a full year. By the 2050s, we're seeing that increase by 2.6 degrees Celsius, and by the 2080s by 4.5 degrees Celsius. Now, I know mean annual temperature isn't a figure that necessarily means a whole lot on its own, but it does provide a good point of comparison for thinking about overall temperature change in Nova Scotia compared to the global average, for example. But if we relate that to some indices that are a little bit more relevant to day-to-day life, we can look at things like the annual hottest day that we experience in an average year. So for example, in our baseline period, 29.6 degrees might be the hottest air temperature we see in an average year. And again, this is just referring to air temperature, not accounting for humidity here. Whereas by the end of the century, 2080s, we might see 34.4 degrees Celsius as a temperature that we regularly hit in an average year. We can also look at the number of days where certain temperature thresholds are exceeded. So for example, here I have the number of days that exceed 29 degrees Celsius, and this aligns with the typical criteria for issuing a heat warning in Nova Scotia. So historically, we averaged about 2 days per year that exceeded that threshold, whereas by the 2050s, we should expect 14 days or 2 weeks, and by the 2080s, 32 days or over a full month of days that would be under that heat warning threshold. And we're certainly seeing very similar patterns in the number of tropical nights as well that exceed 18 degrees Celsius. So important to note there that it's not just the hotter temperatures during the day that we'd be experiencing, but also the lack of relief overnight that we might typically be used to. If we look at some of our cold temperature indices, we can actually see that winter is warming most rapidly out of all the seasons. So for example, the annual coldest day that we would typically experience in our baseline period, negative 21.9 degrees, might be the coldest temperature we see in a typical year. Whereas by the end of the century, negative 13.6 might be the coldest temperature we see in a typical year at least. We're also seeing things like our average winter temperature increasing from well below zero, negative 3.7 degrees, to above zero, positive 1.3 by the end of the century. And as you might imagine, that has some quite significant implications for the characteristics of our typical winter season and what we think of as a Nova Scotia winter. The number of days below negative 15 degrees Celsius or extreme cold days are also disappearing quite rapidly. So in our historical period, about 15 days per year, we could expect to be below negative 15. By the end of the century, less than 1 will be typical. The number of freeze-thaw cycles that we experience decreasing from an average of 44 per year to an average of 35, and certainly some seasonal shifts taking place within that as well, where we're losing a lot of the freeze-thaw that would typically take place during our spring and fall seasons, with more freeze-thaw taking place during the winter season itself. We're also projecting increases in the length of our growing season from an average of 200 days historically to 230 by the 2050s and 255 by the 2080s. So put another way, that's an increase of about 1 month by mid-century and close to 2 months by the end of the century. And that certainly does present an opportunity for producing more food or growing different crops. But I do also always like to pair that with the caution that it does introduce risks due to new pests, diseases, and invasive species that could impact our native vegetation. So it's an opportunity, but certainly one that we'd have to do a bit of work to take advantage of. And also here, just looking at heating degree days and cooling degree days, which you can think of as the kind of meteorological demand for heating and cooling based on the temperature outdoors. So with warmer winters, we are expecting less demand for heating, on the order of about 30% less demand by the 2080s compared to what it used to be. Conversely, in the summers, as things get hotter, we're seeing a substantial increase in the demand for cooling on the order of about 500% compared to what it used to be. And what that means is that businesses and homes and institutions that have historically not needed to think about any sort of cooling system may need to start looking that direction to properly be prepared and support human and animal welfare. So thinking about some of the hazards associated with these warming temperatures, I just wanted to specifically mention that we can expect increases in the frequency, severity, and duration of extreme heat events. That poses risks to public health. For example, there are notable increases in mortality rates at higher temperatures. Also poses risks to outdoor work and recreation, and certainly many important species and ecosystems that aren't adapted to cope with that extreme heat, and even infrastructure that isn't designed to withstand it. The increased likelihood of hot and dry conditions could also drive up our potential of experiencing drought and wildfire, for example. And even some of our cold weather hazards like extreme cold and large snowstorms will be less frequent, but will still occur. And sometimes those events can be more impactful when we're less prepared for them and they occur less frequently. So we can't be complacent about those either. Moving on to our second key message here, being that precipitation patterns are changing. And again, when I'm talking about precipitation, that's just the word for any water that falls from the sky, snowfall, rainfall, that sort of thing. So looking at the precipitation projections in a similar chart here, but really I'll just highlight a few key trends that it's good to be aware of. First of those is that we're expecting a slight increase in total annual precipitation from an average of 1,315 millimeters in our historical period to 1,456, or an increase of about 11% in a year by the end of the century. However, I think it's useful to note that more precipitation doesn't necessarily result in more available water. So when we think about that increased temperature that I was just talking about in those previous slides, recognizing that that also drives up rates of evaporation and transpiration, so that when rain falls, it doesn't necessarily stay on the ground and in the soil the same way that it used to. As well, when we see warming temperatures, probably not surprising, but we're seeing changes in precipitation type. So we're seeing more precipitation that will fall as rain instead of as snow. So for example, looking at the number of days with snowfall here, historically, we used to have about 39 days per year where snow fell. By the 2080s, that could be decreased to around 17. And just, I guess, putting that in some different contexts. So typically in Nova Scotia's winter season, historically, we had about 60% of our total precipitation fell as snowfall, whereas by the end of the century in our winter season, about 27% of our precipitation will be snowfall. So much rainier than it used to be. And then the final trend that I wanted to point out here is a trend towards more intense rainfall events. So as we can see, there's not really any change in the total number of days where precipitation falls, which means that that greater amount of precipitation is falling within the same number of events, driving up the intensity. So for example, looking at the number of days that exceed 20 millimeters of precipitation, our most intense rainfall events, we can see an increase there from an average of about 16 days per year in the baseline period to 20 days with 20 millimeters of precipitation by the end of the century. And certainly some increases there in our maximum 1 day and maximum 5 day precipitation totals. So as you might imagine, that would drive up our risk of flooding. That leads us nicely into our third key message here, being that we can expect more frequent and intense storms. And really what I'm referring to here are changes to the frequency, intensity, duration, and timing of some of our most intense tropical storm events. So those tropical storms or hurricanes that form in the Caribbean region, make their way up the Atlantic coast and sometimes impact Nova Scotia. And that's driven by warming oceans that enable those tropical storms to travel much further north before weakening. So for example, we can see projections of increased peak wind speeds during these events by about 3.7 to 7 kilometers an hour by 2100. And I know that's not a huge increase, but does show that these storms are slightly stronger further into the future, as well as increases in wave heights by about 2 centimeters per decade in the summer and 20 centimeters per decade in the winter, with a larger change in the winter season due to changes in sea ice and different things like that. And what that means overall is that it's more likely for larger storms to hit Nova Scotia and for them to be more impactful when they do. So as I'm sure you're all well aware, some of the hazards associated with storm events include things like flash flooding, high wind events, storm surge, coastal erosion, and landslides. And these are all photos taken from recent events around the province. And I think it's a nice reminder that we are already impacted by all of these things. And when these events occur and they occur in large magnitude, they can be extremely disruptive. And really, climate change is just exacerbating the risks that we're already facing. Moving on to our fourth key message here, being that sea levels are rising. And I always like to pause on this photo for just a few moments here. This was taken during a storm event in Liverpool, Nova Scotia, relatively recently. And the reason I like to pause here is because there's one quote that's really stuck with me about thinking about sea level rise, and that being that today's storm surge is really just tomorrow's high tide. And if we look at the magnitude of some of the storm surge events that we've experienced recently compared to sea level rise that we're expecting, we realize that those things are somewhat comparable. And if we think about water levels like this being experienced potentially twice a day at high tide, rather than just once every 20 or 30 years when a large storm event hits, we start to wrap our heads around the magnitude of the challenge facing some of our coastal infrastructure and coastal communities. But more specifically, when I'm talking about sea level rise, I just wanted to point out that I'm referring to relative sea level rise. So what I mean by that is that's combining a number of different factors together, both global and regional. So that includes thermal expansion of the oceans as they warm. It includes melting land ice. It includes a vertical land motion. For example, Nova Scotia is slowly subsiding, which is related to the last glaciation that the North American continent experienced, as well as changes in absolute sea surface elevation due to changes in some of our offshore ocean currents as they break down and more water kind of pools against our coasts. But taking all of those things into account together, we can see that sea level rise around, or sea levels around Nova Scotia are expected to rise by about 68 to 100 centimeters by the year 2100. Now I know the legend on this figure might be quite small, so just noting that the greener colors there are more towards the 68 centimeter range, the reds are more towards 100. So from that, we can see that we're expecting the highest increases around Cape Breton and secondarily around Halifax. Also just pointing out that these are mean sea levels and or mean projections. So there are some higher numbers you might see out there if you're looking at the 95th percentile, for example. Also useful to note that this estimate that I'm talking about here does not include potential instability in the Antarctic ice sheet, which could add an additional 65 to 70 centimeters or so of sea level rise on top of that amount I just mentioned by 2100. Now, at present, that's something that's being regarded as quite a low likelihood event, but it would obviously be impactful enough that it's something scientists are watching very closely. And it's something that other jurisdictions are already starting to plan around for some of their most vulnerable coastal infrastructure developments. Also useful to note that actual water levels experienced will still be influenced by things like storm surge. And we've experienced surges of up to 1.6 meters in recent years, as well as high tides and coastal geomorphology. And we'll actually just go through a quick example to show what I mean by that. So here we have some work that one of my colleagues at CLIMAtlantic, Rael Dag, did a number of years ago, showing flooding return periods for different regions. And this is data for Halifax from the tidal gauge here. And again, just highlighting that there are a number of different factors that influence water levels. One certainly being tides, which, as I'm sure we're all aware, result from the combined effects of gravitational forces, most importantly, the sun and the moon. Also, another important factor is storm surge. And if you're not familiar with what I mean by that, that is a kind of a localized pooling of water due to reduced atmospheric pressure and strong winds that sort of result in a bulge of water forming. This is associated with some of our really strong synoptic storm events, and certainly sea level rise on top of that. Wave action is also sometimes accounted for, but sometimes can be a little bit tricky. So those are the three ones you usually see. And we have data here for return periods for different amounts of time. So just to be clear on what I mean by that, return periods just represent the probability of an event occurring in a given year. So looking at a 100-year return period, sometimes called a 1 in 100-year storm. Another way of thinking about that is just an event that has a 1% probability of occurring in a given year. But really what I wanted to highlight here is if we take all of these factors together and look at kind of the most extreme example here, a 1 in 100-year storm for the year 2100, that maximum sea level rise occurring at high tide. We can see a projected maximum water level there of about 4.17 plus or minus 0.58 meters. So if we take the kind of the maximum there of about 4.2 plus 0.6, say, that gets us relatively close to 5 meters as being certainly a very rare event, but something that could plausibly occur. And we'll go to the next slide to just see what an example of that might look like on the ground is. So this is an example of a flood visualization. The images here show the Halifax Peninsula. On the left shows 0 meters of water level increase, whereas on the right is that 5 meters of increase. And as shown on the previous slide, that is something that is plausible if very rare. This is information coming from a really great online tool called the Maritime Coastal Flood Risk Map, through work done by the Applied Geomatics Research Group out of Nova Scotia Community College. And it's based on LiDAR data, which is which can be used to create a very accurate high resolution digital elevation models. So what we can see here is basically by dynamically raising and lowering water levels to show what we'd be experiencing under different sea level rise scenarios or different storm surge event conditions. We can see that these types of projections and visualizations can be very effective for understanding what is at risk, both in terms of potential infrastructure damage and flooded properties, as well as things like transportation routes that are cut off and disrupted access to emergency services. So this is a tool that unfortunately doesn't cover the entire province, at least yet, but we do have LiDAR that has been flown for the entire province. And while there isn't a flood risk viewer like this for the entirety of Nova Scotia just yet, there's a lot of conversation ongoing about how to get there. Just wanted to address that because I know it's certainly a common question. And both New Brunswick and PEI have both recently launched portals like this for public access. And the hope is that we'll have something like this for Nova Scotia at some point in the coming months or coming years. So just to highlight there some of the hazards associated with sea level rise, I think coastal flooding and storm surge are quite obvious ones, but also things like saltwater intrusion, which can reduce the availability of fresh water in some coastal aquifers and impacts on coastal ecology as well. So for example, some of our sensitive coastal ecosystems like dunes and salt marshes may not necessarily be able to keep pace with the rate of sea level rise that we're expecting to experience, particularly where they're already constrained on the back end by things like dikes. But moving on to our final key message here is that our oceans are changing. And here we'll start with just a quick look at projected changes in sea surface temperatures. This is coming from a slightly different data source. So just to mention, this is from the IPCC's Working Group 1 Interactive Atlas, which is a new online tool, and you're free to play around with that as well. But what this is showing is sea surface temperature projections around Nova Scotia projected to increase by around 4 degrees Celsius by the end of the century 2100 relative to 2010 or so. And I think that's useful to reinforce that the temperature increases that we're experiencing are not just in the air, our waters are also warming by a similar magnitude. We also have projections here for ocean pH because our oceans are slowly becoming more acidic as well with the increased carbon dioxide concentration in the atmosphere. That's changing ocean chemistry. So basically prior to the Industrial Revolution, the average pH of our oceans was about 8.2. Today, that's been reduced to about 8.1. And that might not seem like much of a difference, but for those of you without a chemistry background, just know that the relationship between pH and acidity is logarithmic, which means that each decrease of 1 pH unit is a 10-fold increase in acidity. And looking at the projections towards the end of the century, we can expect the pH of the oceans around Nova Scotia to decrease by a further 0.4 units, down to about 7.7. So just to highlight some of the conditions and hazards associated with these changes, those increased ocean temperatures that I talked about, both at the surface and in deep water, have consequences for physical oceanic processes, as well as different habitats and species. And we're already seeing things like marine heat waves becoming longer and more frequent. The ocean acidification driven by that reduction in pH that I just talked about can corrode mollusks, crustaceans, and corals, as well as diminish the productivity of ocean waters and result in an increased likelihood of events like algal blooms, which have the potential to harm or kill fish in larger numbers. And another trend to be aware of is that we're seeing a trend towards decreased marine oxygen levels, and that can reduce species growth, reproduction, distribution, and survivorship. as well as result in the decline of important habitats like eelgrass beds that filter water, stabilize sediment, and provide habitat for many of our commercially and recreationally important fish species. So getting towards the end here, and I know that was a lot of information to cover. I hope it was useful, but if all of the specifics are just going by a little bit too fast and furious, if you're walking away with anything from this presentation here, I think these are the key messages to be aware of. So again, it's getting warmer in our province. Our precipitation patterns are changing. We're expecting more frequent and intense storms. Sea levels are rising and our oceans are changing. Also, just a reminder here that this presentation really is just an overview of some of the climatic trends that we're expecting in Nova Scotia. There is a lot of additional information available for different parameters, different geographic regions, more specific regions, different time periods and different scenarios. And if you would benefit from any assistance in accessing, understanding, and applying information about climate change in Nova Scotia, please do reach out. That's part of what I'm here for and what CLIMAtlantic is here for, in helping assisting Nova Scotians with that. So final slide here, and I just wanted to wrap up with the question of, well, if everything I've just talked about represents the scope of climate change problem facing Nova Scotia, what on earth do we do about all this? So without getting into too many of the details here, I just wanted to highlight two equally pivotal complementary approaches, and it is abundantly clear that we do need both of these. So one is mitigation, which are actions to reduce emissions that cause climate change, which certainly makes sense. You know, if we know that greenhouse gases are causing climate change, reducing our greenhouse gas emissions seems like a logical step to working towards a solution. So that includes things like working towards more sustainable transportation, clean energy, and energy efficiency. And this other kind of bucket of action is what we call adaptation, which are actions to better understand and address the risks that we know we'll be facing, and even prepare for some of the new opportunities that we know are coming as well. And that includes different planning processes, as well as actions like flood protection or infrastructure upgrades. And certainly there's areas where mitigation and adaptation relate as well, for things like pursuing more local food production, expanding our urban forest, and working towards better conservation of water. And education as well is one strategy I always like to highlight, and it's one that you're all currently engaging in. So kudos to you for taking some important steps down this road. But really, I hope what I've talked about over the last 40 minutes or so here, it does help to reinforce the fact that our changing climate will impact infrastructure, ecosystems, public health, and ultimately ways of life in Nova Scotia, which is why mitigation will be crucial to avoid the most severe impacts that I was talking about, as well as why adaptation will be necessary to adjust to the changing climate for those things that we know are coming in the decades to come. So this will be my last slide. I'll just leave this up here for a moment. It does have my contact information if you'd like to jot this down for any reason. You can also find this on climatlantic.ca if that's useful. But just a few final comments here before I stop talking. So the climate data that I've been talking about here does, I think, tell a bit of a concerning story. There is certainly a lot at risk, but I think it's also important to recognize that there's a lot that we can do. So with scientists, government, businesses, and communities working together, we can reduce further damage by mitigating our greenhouse gas emissions, and we can plan for and invest in adaptation to prepare our province for climate change, and ultimately work towards the goal of improving the well-being of Nova Scotians and ensuring that no one is left behind in that process. So the future is ours to shape. I hope the talk here has been useful for you, but I'll wrap up there and leave us about 15 minutes or so for questions. Well, Olio, thank you, everyone.
Yeah, thank you so much, Alex. It's very informative. And just to let everyone know that we will be putting together a recap of the event this evening, and we will email it to everyone with Alex's contact information, along with the video as well. So if you want to rewatch it or share it with any of your colleagues, you can do so. We had a few questions come up through the chat. So maybe we'll start off there, Alex, and see if we can answer a few of these questions. Paul Strom was interested in the Atlantic Loop. So getting our 8 fossil fuel fired electrical generating stations and the 2 biomass plants should be a primary initiative by implementing the Atlantic Loop. but where does that stand at present? I'm not sure if you could comment on that.
Yeah, great question. It's not my area of expertise. If anyone does have information about that, I'd be happy to hear it. But unfortunately, Paul, I don't have more to tell you about that one right now.
Does anyone have any questions that are not in the chat? Oh, we have a few people raising their hands, so just one moment there. We have a question from Lee.
Oh, I'm on. Thanks. Hi, Alex. Great presentation. It was nice. I mean, I think a lot of us have probably seen, maybe not the level of detail, but at least some of that information before, but it's important to really hit that home. I'm a high school teacher at Horton High School, and I'm really wondering what kind of materials are available for us to make sure, as educators, that we're really getting this information, especially as it's constantly being updated out to the next generation.
Yeah, fantastic question, Lee, and certainly a common one that we get. I know, at least on my end, working hard to get information like this a lot more publicly accessible. We're doing work right now to get a short video produced covering a lot of this information, put some infographics together that could potentially, be printed and put on classroom walls, things like that. We've had some initial conversations with some of our colleagues in education and early childhood development, the science consultant there, to try and better incorporate information about climate change ultimately into some of the science curriculums that Nova Scotian students are engaging in. So that's sort of where we're starting, but as always, looking for other ways to get information like this into the hands of our youth. They are certainly pushing the agenda forward and will ultimately be the leaders on a lot of these initiatives. But certainly a lot of the NGOs working in this space as well. Clean Nova Scotia, the Ecology Action Centre have different programming related to climate change and getting that into schools as well. So I'll just highlight some of that, and I'd be happy to pass along some more specific examples at a later date.
Yeah, please. And also consider Citizenship 9 and Global Geography 12. It'd be nice to kind of integrate this into a lot of our curriculums.
Great, thanks for the question, Lee. I'm going to move on to Reb. I think I might have missed you, but oh goodness, asked to unmute. You should be good there now.
Hello, thank you, Alex. What a great presentation. I really appreciated all the information that you shared, and I think it's really well put together, and there's some significant information that we've been offered. One gap that I see is that you didn't really talk so much about the biosphere and how these climate changes are going to change the biosphere. So that's kind of, I think, an indication that, as you suggested, education is really important, but also a lot more research. Like, we need more people kind of out there gathering data. Would you not agree?
Yeah, that's a great point, Reb. Thanks for raising that. And yes, I suppose I should make clear that you're sort of only getting part of the picture here today, talking about how the climate is changing. There is other portions to this as well, which is what does that actually put at risk, and what do we do about it, which I only briefly was able to mention towards the end there. So one thing that we can specifically look forward to within the next couple of months is Nova Scotia, the provincial government is currently putting the finishing touches on a provincial climate change risk assessment, which does get into all aspects of impacts of climate change, using the projections I just talked about as a starting point, how that impacts natural capital, social capital, infrastructure, what's most at risk in Nova Scotia, things like that. So that's a pretty major document that will guide policy and research development for a number of years to come. And perhaps maybe that's an opportunity for a future webinar, but it's not quite ready for public release yet, but it's certainly getting close.
All right, thanks for the question. We're going to move on to Michaela Cole.
Right, thanks, Dylan, and thanks, Alex, for your presentation. So I have kind of a curiosity question here, and I'm looking for your opinion. So I'll ask, how soon do you think we could be expecting a massive global climate refugee crisis? So I know that the Pacific Islands are already really experiencing a crisis like this because of rising sea levels, and a lot of port cities around the world are located only like a few meters above sea level. So Do you think this is an immediate issue we should be looking at?
Yeah, that's a good question, Michaela. And certainly timeframes are difficult to put on it because really it's when a major event happens, that's when the crisis will hit. You know, looking even like a country like Bangladesh is brought up as a pretty common example where I think about a third of the country is located within about a meter or a few meters of relative sea level. And a very densely populated country. And certainly there's other examples of that around the world as well. So if areas like that don't get hit with large storms, it might be a number of decades into the future. Whereas if that storm were to hit tomorrow, and those things are certainly possible, we could be facing these types of crises possibly sooner than we're prepared for them. And we're seeing, you know, often these types of very complex international aspects to climate change compound other risks. So, you know, for example, there are indications that some drought conditions in Syria were one of the inciting factors for the conflict there, other examples like that. So I know it's something that at least at the national level is being discussed. I'm not part of those conversations, but certainly preparation and what Canada's position will be when those events occur. And it is a question of when, not if. Those are important considerations, absolutely.
All right, we'll move on to Paul Strome.
Hi, Alex. Thank you again so much for your presentation. You know, I noticed that, you know, there's about 27,000 different spots around the world where information is being gathered to give this picture to us, and it's been there for a long time. Now, we've had Seth Klein, you know, and many other people writing about this for decades. And so politicians especially, they're the ones that are supposed to be our leaders in this country and all over the world. And they've known about this for so long. So have presentations like this been shared with politicians at every single level of our government? And if so, is there a list that we can see about where that's been done?
Yeah, good question, Paul. And to that, I can say yes, at least in recent months. My position with CLIMAtlantic and the Nova Scotia government, I've only been in this role for about 6 months or so, but in that time, yes, I've absolutely briefed everyone within our Department of the Environment, from the minister right on down. I've had a chance to talk with senior government leaders across all departments through some professional development work there. So it's not to say that there's a list of that necessarily, but they are things that are happening. And certainly part of my role as well is to work directly with and support municipalities and Indigenous communities and others that are trying to better understand this information. So trying to be a resource of this type of knowledge for those folks as well, which is really just to say that if any Nova Scotian is reaching out looking for information like this, they're getting a very similar briefing from me, whether they're a politician or senior official in government or a private citizen trying to better understand this. And I think that's important because when we're all working from the same knowledge base, we can have fewer conversations arguing about what the information is and work towards more productive discussions on what do we do about it, because there are a lot of practical considerations that we need to think about as a province. But ultimately, if our citizens are well informed, then I'm going to be relying on you as fellow Nova Scotians to exercise your rights as citizens and as consumers to vote for and spend your money in ways that align with your own values.
Thanks, Alex.
Yeah, thanks, Paul, for that great question. It's important to get the politicians involved for sure. I'm going to pass things off to David Stewart.
Thank you. A couple of things. I know Tim Holman pretty well, and I think he's taken on a very good task. The question is, to me, is if the federal government has declared a climate emergency and HRM has declared a climate emergency, do you think the province should declare it a climate emergency, and what form would that take?
Yeah, that's a good question, David. And I know the declarations of climate emergencies are certainly becoming more common in different political jurisdictions around the province, or sorry, around the country, I should say. As to whether that's something Nova Scotia is currently considering, I don't have any information about that.
The
I
question
guess
is,
really-
would it help you? The question is, would it help your job to basically, would it give you a little bit more teeth or credibility when you walk into somebody that says, I don't know about this climate change, and you go, well, take a look.
Yeah. Oh, thanks for clarifying there, David. Really, I guess from where I'm sitting in my role, and again, I do work directly with the provincial government, I don't think that there is any lack of understanding of how urgent matters are. Even just looking at how our team on climate adaptation has grown since I've joined, and seeing some of the different initiatives that are underway. It is an incredibly hardworking small group of people doing work on adaptation planning across government departments and with external stakeholders. All the work that I'm doing around data and research, the risk assessment that I mentioned. There's a full climate plan that's coming out in the near future as well, related to the Environmental Goals and Climate Change Reduction Act that was announced last fall, outlining exactly what Nova Scotia will be doing to work towards that. So there's a lot happening. So I couldn't necessarily say whether a climate emergency declaration would make any of that better. It's kind of already happening. So we'll see if that's something the government is interested in, but at the very least, there's a ton of work happening in the background.
Well, my final comment is, with you around, I feel a little more confident that the new administration will be bold and will start to do something, because what you've painted right now is a very scary scenario.
Yeah, and we've certainly heard that message from decision makers right on down. It's sobering information, and it does very clearly reinforce the need to act. Thanks, David.
You're welcome.
Thank you for that, David. We're going to move on to David Wimberly.
I'm sure glad that you're finally taking seriously the upper end projections. As little as 10 years ago, most people going around lecturing were looking at the lower end, assuming that we were going to do things right. And so given that, it's really only a matter of time before our link with the mainland washes out. And that and if it happens several times, there's not going to be money to replace it. It's just a sandbar, the Tantramar Marsh. And then we don't have food. We ran out of food in 3 days. We don't have energy. We can go on and on and on. We see just how our resilience is lessening, not increasing. It's getting worse, not better. So how do you propose going about relating to that in a way that gets real results, both what individuals can do and what government can do? I mean, I know with Transition Basic Margaret's, we're helping teach people how to prepare themselves for all of these things in an uplifted way. But what do you propose?
Yeah, a few good points there, David, and just sort of around the Tantramar Marsh area. Yeah, that's an area that gets a lot of attention in our province, and it's, I mean, for good reason. I sometimes hear the idea of Nova Scotia becoming an island, and there's really no immediate concern of that, but we don't have to become an island for that transportation corridor to wash out during a major storm event. And even if we're cut off for a period of days or weeks, that would be incredibly impactful, right? So there are multilateral discussions taking place between provincial governments and different municipalities, and a lot of good work taking place to plan around adaptation in that area specifically.
Well, the Saxby Gale almost washed that out in, what was it, 1887, I think, or right around there. And now with sea level rise and heavy storms, I think it could happen any year, almost any time. And so I think that is one of the most amazing things we have to do. And then we starve here. And then we don't have any food. And then most people can't keep their houses warm without electricity. And we often see that. So what are we really going to do? Not just say we're thinking about it, but really, what are we going to do?
Yeah, great point. And again, I think that comes down to ultimately working to build the adaptive capacity and the resilience of our province. that works towards things like expanding local food production and local energy distribution, and all of those things that increase the self-sufficiency of Nova Scotians. And particularly when thinking about climate change, you often hear the idea that it's the most vulnerable that are going to be most heavily impacted, those people that don't have the ability to move somewhere else or to go live in a hotel for a few weeks and pay for that if they're flooded out, things like that. So there's a really strong lens on, as I mentioned towards the end, making sure that nobody is left behind, trying to hear from these voices that have been traditionally marginalized or racialized or just not included in these types of conversations. So that's certainly a major focus as well. And I could probably continue rambling, but I know we're a little bit past 8 here, Dylan, and I don't want to keep everybody too long here.
Yeah, David, thank you so much for that question and all the great questions that everyone had asked. And I'm sorry if we couldn't get to the rest of the questions, but we will, like I said, we will be sending a follow-up email likely tomorrow, just recapping the event, and we'll also provide Alex's contact information. So I'm sure he'd be happy to answer some of these questions that we couldn't get to this evening. So again, I just want to thank everyone who attended the event from all across Nova Scotia and Canada as well. This was one of the larger events we had. I think at one point it was 85 people on the call, so that's amazing. And yeah, you know, keep an eye out for future events. We're hoping to do a few more of these types of events. And yeah, thanks so much, Alex and Jeff and everyone for joining the call this evening. And I hope you have a great night.
Yeah, thanks so much for the platform, Dylan, and for all the work helping organize. I hope everyone found the information interesting and useful, and do please enjoy your nights.